So today I'm going one of the topic for data architecture, and we are talking about modern and previous architecture. So let's go with this is very important. Those people who want to become a data architect, or their goal is become a data architecture or the head of the data, similar profile. So the growth of data infrastructure is tremendous. Before 2020, after 2020, data roles and keep increasing nearly like the industry metrics hit records and during the past years, and new product category appeared in faster than most of data teams could reasonably keep in track. Even the benchmark for billboards better written to help the data teams stay on the top of change happening in the industry. They saw the current base class stacks across both analytics and operation system. So I'm going to talk about this one like current trends and previous trends, and this is the numerous things which we talk about with various data engineers and past and present. So I'm going to show the modern data structure as well as the previous one. With the core data processing system have the remained relatively stable. So core data processing is not much change, but emerging technology like the front end tools and those things are keep changing. We explore the hypothesis platform beginning of emerging the data ecosystems, and this helped explain the particular patterns we are seeing in the evolution of data stacks. To compile this work, we rely against input from the dozen of data experts who listed in the end of the post. This is simply couldn't exist without two of them. So this is unified data structure before 2020. So we have source could be the oltp database via cdc, change data capture, erp system like salesforce and oracle, operational apps like mysql, salesforce, hubspot, zendesk, event collection like segments, snowflakes, click streams, logs, third party api easy, stripes, file and object storage. So this is the sources, and injection and transport layer like transporting data from one to. So if you have track one place to another place, similar data injection. So some people use five tran, stitch, medallion, airbytes. The workflow manager, airflow, astronomer, perfect, elements and designer. Event streaming, they use the kafka and kinesis, pulsar, absolver. And for ETL, high touch and sensors, data discovery, they use data hubs, which also we use at Lion and Alasians. And data governance, Colaboria use data observability, also use different thing like great explanation and various and entitlement and security. We also use immutability. So this is the previous architecture, and then this is the whole the data warehouse. There is the amount of two parts: data lakes like Delta, Tabular, and Iceberg, Kudi, Parquet, ORC, Avaro, S3, GSE. This is the data lakes, and the platform is a Spark platform, a SQL Query Engine, DSML platform, and the data warehouse could be the Snowflakes, BigQuery, and Redshift. Right? For real time, most of data read from Kafka, and the real time usually like Flink, ClickHouse, RocketSet, imply. So there is a streaming processing, real time analytics. So this is for analytics. This is for processing. And then we have the transformation layer, data modeling, workflow managers, and metrics. The modeling basically uses SQL. Data metrics, LookML, transport, sequential DBT, and the dashboards we use Looker, Superset, Tableau, Sigma, embedded analytics, and argument analytics, data workspace, DSML trainings, app framework, custom applications. So this is the previous, 20. So unified data structure, as I say, is they have source layers, then injection layer, then storage layer, then query processing and transport and query analytics. And similarly, this is the machine learning layers. They also have data source and then data labeling for data transformation, query engine for use data science and libraries. Most of tools are similar like Spark, Pandas, NumPy, machine learning platform. They use this one. And low code ML, so then the ML framework, DL framework, RL libraries, and then on top of that, workflow managers and batch predictor, online real-time predictors, and pre-trained model strategy compiler, validator. There are various things. So this is, now we are talking about so the core concept here, we are talking about the stability in the core. Despite all the frenzy and data infrastructure activity over the past year, it has surprising to see in some way. So it has to the stable. In our first step, we draw a distinction between analytic systems that support a data-driven decision making and operational system to power of data-driven products. Okay, then we map category and then three patterns and blueprints. So we are going to talk about analytical system and operational system. Analytical system use make data-driven decision, build a data-powered product. Modern business intelligence, multi-model data processing, AI and machine learning. So AI machine learning operational system build data-powered products, and this operational system is mix, and this also mix. One of the key question was here whether these architecture patterns would be covered. As a past later, this doesn't mean to have taken place. In a particular analytical operation and ecosystem, both continue to thrive. Cloud data warehouse like Snowflakes have grown rapidly, focus on largely on the SQL user and business intelligence use case, but adoption of other technology has also accelerated. Data lakehouse like Databricks, for instance, are adding customers faster than ever. Many data teams were spoke with confirmed heterogeneously likely to here to stay with data stacks. Other core data ecosystem, namely injection and transformation, have proven similarly durable. This is especially visible in the modern business intelligence pattern, where the combination of 5TRAN and DBT is a similar technology has become a nearly ubiquitous, but it is also true extent in the operational system, where the fact standard like Databricks, Spark, Kafka, and Airflow has emerged. What new in around a stable core data stack has been rapidly over the past year. Broadly spoken, we have mostly has two cases. New tool designed to support key data process and workflow like data discovery, observability, ML, and model review. New application that allow data team business to user to generate values of data from new, a powerful way like data space, reverse ETL, ML application framework. We are also seeing the introduction of some of new technology designed to enhance our data processing system, and notably there has been active data around the matrix layer. So this is how the modern business intelligence, if you see here, right? Source, OLTP database via CTC, ERP, operation apps, event collaboration log. This is same. Data replication is also same, and then the reverse ETL is the new, and data warehouse, and they have on data discovery, data observability, matrix layers, data workspace. So combination of data replication like 5TRAN, cloud data warehouse like Snowflake, SQL-based modeling with a DBT continues from core. This pattern is adoption of for these technology grown meaning from funding and early grown new computer like Airbyte and Firebolt. Dashboard continued to be the most common application used in the output layer, including Looker, Tableau, Power BI, newer entrants like Superset. This is the new things. There has been the surge of interact with the matrix layer and system providing a standard set of definition on top of data warehouse. This has been mostly debated, including what capabilities should have, which vendor should own it, what specs should be followed. So far, we have seen several credible pure platform like Transform, Supergain, and Plus. Reverse ETL data teams are showing the stronger interest in new application. Data discoverability and observability company have raised a substantial amount of capital. So Monte Carlo and Bitcoin. So this is the new things. While the benefit of these products are clear, that more reliable data pipeline and better collaboration, adoption is still relatively early as customers discover relevant use case and budgets. Technically not, although there are several credible new vendors in data discovery, easy, select Star, Metaphor, Schema, Xerox. Sir, we have excluded those series companies from the diagram of general. So multi-model data processing, injection layer, workflow manager, airflow, event streaming, then data lakes. So Delta, Iceberg, Hoodie is a new player, data streaming, data breaks, Confluent, Flink, data discovery, data observability, core system in data processing, Databricks, Starburst, Premia, transport is a Confluent and Airflow. Storage AWS continue to grow rapidly from the backbone of this blueprint. So they continue to grow and using multimodal data processing remain the diverse in design by allowing company to adopt system best suitable for their particular needs across both analytics and operational data application. What's the new? There is a growing recognition of lake house. So where is the lake house? Lake house. This is the lake house. So it's growing. Okay. And fundamental value of Lakehouse a robust storage layer with array of powerful data processing engine like Spark, Presto, and ClickHouse Python library etc. Storage layer itself getting upgrade, while technology like Delta, Iceberg, Hoodie are not new. They are seeing the accelerated adoption and being built into commercial product. Some of these technology, Iceberg is also integrated with the cloud data warehouse like Snowflake. If the heterogeneity here to say they are likely to become key part of a multi-data model. There may be upstick and adoption taking place of streaming process, real-time analytical data processing, while the first generation technology like Flink still haven't gone the mainstream. New entrants with the similar programming model like Materialize and UpSolar is gaining early adoption, and inceptively use of stream processing and product from the Iceberg Databricks and Confluent has also started. Artificial intelligence also going to change, remain the same, but new adoption and technology also the same. So let's talk about. So what has not changed from 2020 to now? Tooling for modeling development largely similar to today to compared to 2020, including major cloud vendor Databricks and AWS and ML frameworks. XGBoost and PyTorch are experimental management tool, and these are experimental management has efficiently subsequent model when visualization and turning independent category. What new ML industry is consolidating around a data centric approach, emphasize on sophisticated data management or incremental modeling improvement. This has impact. Rapid growth for data labeling, easy scale and label box and growing and closed loop data engine. Increased adaptation for feature stores that Tecton is both batch and real-time cases. Receive interest with low-code ML solution like Continuous and MindDB that list particularly. So these are new things. Use the pre-trained models, and those are continuously. So data platform hypothesis. To recap, over the past year, data infrastructure stacks has been substantially stability in core system and rapid proliferation and supporting tools and application. To help explain why this might be happening, we are introduced here the idea of data platform. What a platform? The word platform, overloaded and data ecosystem often used by internal team and describe their whole stacks or the vendor to sell the loosely considered product. In a software more broadly, platform is something other developer can build on top of it. Platform are generally provide limited value of their own, most use have no interest. For instance, accessing the guards of Windows or iOS, but they are provide area of benefit like common programming interface and large install base that allow to develop, build, and describe the application user of ultimately cover. So defining trait and platform for industry standpoint in the mutual dependency, both technology and economically between the influential. So platform adoption, the lot of user will adopt and they will use. So what data platform? Historically, data stack has not been the obvious fit of the definition of the platform. Mutual dependency exists among the ETL, data warehouse, and the reporting vendor, for instance. But integration model trend to be one by one rather than one to many on was supplemented by heavily by professional service. According to number of data experts we spoke with, this may starting changing. Platform is hypothesis argument to the backend of the data stack. Defined data injection, storage, processing, and transformation has started consolidated around a relatively small set of cloud-based vendors. As a result, customer data is being collected in the standard set of system, and the vendor investing heavily make this data easily accessible to other developers. Fundamental design principles to system like Databricks via SQL standard plus custom compute API in the system flow. Front-end developer in turn have taken advantage this single point of integration to build a range of new applications. They rely on clean joint data and warehouse lakes and without worrying about the underlying details. How they got there. The single customer may buy and build many applications on top of the data system. We are even starting those system traditional. So this is the data source, integration transformation, cloud data warehouse, data lakes, and observability on top of governance observability tools. On top of this, application data overloaded, embedded analytics, data workspace, in-process feature, ETL, CRM, finance. To be clear, doesn't mean the OLTP database or other important backend technology will disappear in the near future, but natively integration with OLTP system may become a critical component of application development. And over the time, more and more business logic and application functionality could transit this model. We may see the whole class of new product built on this data. The emerging emergence of data apps, the data platform hypothesis is still very much open to debate. However, we are seeing increased sophisticated vertical SaaS solution implemented in horizontal layers and top of the data platform. There are many reasons. For example, companies like Snowflake and Databricks have become the stable piece of the data stacks, including the great product, capable sales, the team, and low friction development model. But there is also case to made to their stickiness and for platform dynamics. So there is keep evolving the data resource. So we are going to publish. Thank you for watching. Please like and subscribe my channel.